Hello everybody and welcome back to another visual pattern challenge. Here is our challenge today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of stars in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of stars in any step at all? That's the challenge. If you'd like to accept it, pause the video and work it out. Okay, so this is a bit of a strange pattern compared to others we've looked at before. There are no stars in step 1. So we've got this sort of grid behind it, but we're not counting the lines or the squares in the grid. We're counting the stars, and it looks like, yeah, it looks like they're filling in the stars except not on the corners. So a star goes on every intersection, but not on the corners in each step. So if I wanted to predict the number of stars in step 4, this is a 1 by 1 grid, 2 by 2, 3 by 3. I guess I'd make a 4 by 4 grid and fill in all the stars, but then not the corners. Instead of drawing that grid, I'm going to visualize this in another way. So here, the horizontal is a 3-star line. Here we've got 2 horizontals of 4 stars. So I think I'm going to have 3 horizontals of 5 stars in that 4 by 4 grid. And then what's left is the top and the bottom. In step 2, it's 1 and then 2 each on the top and bottom. So I think I'd have 3 each on the top and the bottom. So 5 and 5 and 5 is 15 plus 6 more is 21. So I think we're going to get 21 stars in step 4. If this little diagram didn't make sense to you, draw out that 4 by 4 grid and then fill in stars on all the intersections except the corners, and you should come up with 21, I think. Okay. So what is going on with this pattern really? My guess is that it's quadratic because we have this pattern of increasing squares, but let's analyze the numbers to make sure, or to see if there's some surprise. So I'll make a chart with the step number and the number of stars. So in step 1 we have 0 stars. In step 2 that's 5. In step 3, 8, 9, 10, 11, 12. And in step 4 we're predicting 21. So let's take the difference between each step. 5 minus 0 is 5, 12 minus 5 is 7, and 21 minus 12 is 9. So we didn't get a constant in the differences, which means it's not linear. So we can take the difference of the differences. So 7 minus 5 is 2, 9 minus 7 is 2. Here's where we're getting the constant. When you get the constant in the difference of the differences, it is quadratic. So there's an x squared going on in this. But from here, it might be easy to get stuck because it's not obvious how the x squared fits into these shapes up here and what else is going on in the equation. You know, one strategy when I come up with that quadratic is maybe to look back at each step and block out an x squared and see what's left over. Hard to do that in step 1. There are no stars at all, so you can't block out an x squared there. And the other shapes don't really lend themselves to that either. And then just looking at the numbers, honestly, there's no square pattern that just jumps out at me there. So I'm a little bit stuck at this stage. And I think it pays then to look back at your visual intuition that you started with. We talked about how this was a square grid without the corners. And I think that's how we need to make our equation. So let's just imagine for a second that the corners did have stars. So let's do that for the first 2 steps. So I've got stars on the corners now. And what that means is you actually get a 2 by 2 grid in step 1 and a 3 by 3 grid of stars in step 2. If I wanted to express that in an equation, it would be the step number plus 1, right? Because in step 1, this is 2 by 2, and in step 2, it's 3 by 3. So step number plus 1, and then square that. And then I could take away the corners. And each time it's just those 4 corners, right? So 4 corners here in step 3 as well. So I could just subtract 4. So in this part, I make that grid that's 1 bigger than the step number. Then I take away the corners. I think this is going to be our equation. And you could, FOIL this out, x squared plus 2x plus 1 minus 4. And this would be, minus 3. I don't think that actually gives you any insight to this pattern, so I'm not going to worry about that. I'm going to write this equation as x plus 1 quantity squared minus 4, because I think that gives us better intuition into this, the visual nature of this pattern. But let's test this. Let's make sure. So in step 1, that would be 1 plus 1, quantity squared, minus 4. Well, that would be 1 plus 1 is 2, squared is 4, 4 minus 4 is 0. Yes, that's how many in step 1. Here we'd have 2 plus 1, quantity squared. That'd be 3, 9, minus 4 is 5. Yes, and you can go ahead and test that with 3 and with our prediction for step 4. I think you'll find this works well. And once we've got this, figuring out how many in step 43, not too tough. We just simply put 43 in for x. So 43 plus 1 would be 44 squared, and then minus 4. And 44 squared is 1,936. Subtract 4 from that, we get 1,932 stars in step 43. Well, how did that go for you? I think this was a really tricky equation to get. Did you get stuck along the way, or did you see this? Did you use your visual intuition like I did, or did you arrive at an equation like this in some other way? I'd be interested to know. Thanks, everybody.